Hi, everybody. Thanks for joining me. My name is Josh Lee. I'm an open source developer advocate at Altinity. We do managed services and expert consulting for ClickHouse. And today we're going to talk a little bit about ClickHouse and how it could potentially be used as a unified observability database for all of your telemetry signals, mostly coming from OpenTelemetry. So let's dive in. So I talk about OpenTelemetry a lot, and when I'm talking about OpenTelemetry, I usually get to a point where I show a slide that looks something like this. And I talk about how we build our pipelines and instrument our services, use the OpenTelemetry collector, and then we can use all of the exporters available in OpenTelemetry to send the data to our various different backends. And this is great for explaining the OpenTelemetry project and how it works, but it's actually not an architecture that I would like to use, right? And it kind of hides some of the complexity that exists on the left-hand side of that chart in our services. The OpenTelemetry project itself does not include any kind of database or backend UI. So for everything on that right hand of the chart, we're kind of just left to ourselves or to work with vendors, right? And that's partly by design, but there are some things that we can do about that, right? And there's another fact that I think is really relevant to this conversation, and it's most of us have at least 6 or more observability tools deployed in production, right, to do various logging metrics, tracing all of the different things across all the different technologies that we're trying to monitor. And because of acquisitions and different teams' preferences and things like that, we end up with a menagerie of observability tools that we need to deal with. So wouldn't it be really cool if we could actually have something that looked more like this, right? We take all of that complexity on the left-hand side where our services live and put it through a unified pipeline, which exists now in the OpenTelemetry collector, where we can manage all of the filtering and sampling and processing in a central place, right? That's very easy to manage. And then we can funnel all of that data to a unified storage. So that's what I'm going to talk about, some ways that we could do that. So some of the challenges, right, with the way that architecture works with the 3 different databases broken out. I mean, this actually isn't a bad choice, right? There are different considerations that need to be made for logs, metrics, and traces. For logging, you need efficient full text search and you need just massive storage, right? For metrics, you really want something with columnar storage and really efficient compression. And for tracing, you need the ability to handle the cardinality and the metadata, right? And the relationships between all the traces, and also, again, handle the volume, which is going to be immense. So it can kind of make sense that we would build different tools for each of these different things, since they have these different considerations. But that's also at odds with the other engineering consideration, which is we should have fewer tools for the job. I think it's awesome now when I'm using the OpenTelemetry SDKs that I can go in and use a single tool for all of my observability signals instead of having to install a different tool in each one of my programs for each different observability signal, right? It's great to have that single tool. There's just a convenience factor there. And then more importantly, right, it actually allows for us to do stuff with the data once we've got it all in the same place that right now is happening inside our senior engineers' brains, right? We're kind of doing the joins in our head. We've got our battle stations with like 6 different monitors and all of our different tools, and we're pulling the logs over here, and we're looking at metrics and alerts over here, and we're responsible for doing all of these joins and identifying, is this resource or entity that I'm looking at the same thing in this tool and this tool, is tedious. And when we're responding to a production incident, any amount of tedium, any amount of friction is only going to slow us down and cause more brittle and, prevent us from lowering our MTTR and responding effectively. So it behooves us to minimize that as much as we possibly can. And that's really why I think it's beneficial to bring all of this information together into one place where we can start to look at the metadata that's coming in across the telemetry, and it's coming in a standard format, and we can use that to do the joins inside the tool. We can do background processing, right? There's a lot of things that we can do once we have all of the data in one place that we couldn't do or would have required more steps when the data was in different places. And let's talk more about some of that. But first, let's talk about what we're actually dealing with, right? I've been saying data, I've been saying telemetry signals a lot. So just a quick taxonomization of what we're actually throwing into our databases here when we're dealing with an observability tool. So of course we have the signals themselves. That's fairly obvious, right? We have to store those, and that's where the bulk of our data is going to be. And that's why we need to start looking at tools that go beyond traditional OLTP databases. Then we have the resource metadata. This is actually the interesting thing for the joins, right? For the correlation. Whenever we talk about context and correlation, actually what we're talking about is resource metadata and using that to derive the graphs and topologies, right? To derive the dependencies between the various resources. Resources is the OpenTelemetry word for entities, right? So just if you think about any kind of physical entities inside of our system. And we need to know all of the dependencies between them and how they relate to one another and how they can cause each other to fail. So that's where we get these graphs and topologies that it can be very useful to store those. So storing those, that means we need a way to like create a snapshot in time because these systems are very ephemeral and things are changing, right? So we create snapshots and we can calculate deltas from our snapshots. And then finally, of course, we have configuration. So this is your things like your dashboards, your alerts, and your users. And this actually is fine inside a traditional relational database. So is there a silver bullet for those other things besides the configuration data, right? Is there a silver bullet technology that can actually solve all of these problems for us? Well, no. If there was, right, then Honeycomb wouldn't have had to build their own proprietary storage engine to build the awesome things that they're building, right? We need something that has full text search. We need something that has efficient compression. We need all of these qualities in our storage engine. And there is no silver bullet, but ClickHouse comes pretty darn close to checking all of those boxes. And it can be the foundation of starting to build something pretty powerful. So let's talk about ClickHouse and some of the features that it has that lend it to being an observability backend. First of all, it's SQL compatible. So this is just great for onboarding, right? If you know how to use the SQL database, then you already know how to use ClickHouse as a beginner, right? There's a pretty steep learning curve once you start getting into things, but the beginning is nice and easy for those of us coming from SQL. It is massively scalable. It's horizontally scalable in a way that other relational databases really aren't. And it's really, really fast at both ingestion and querying, like sub-second query times across petabytes. And it's great for observability, right? It has a bunch of things that are really awesome for observability, starting with the storage engine and how it actually organizes the data on your disk. Before we get into that, right, let's just talk about telemetry data. It's what I call worm, or what's called worm. Write once, read many. This kind of just is obvious if we think about it. But telemetry data, we're going to write it at the time that it was created. We're almost never going to update it, and we're going to query it a lot. So we want to organize it in such a way that optimizes for those use cases. Binary trees are a great way to optimize data for efficiency of reads, right? Everything is organized based on the indexes, and we can really quickly walk the tree to find the specific data that we want. The problem is that this can be really expensive for inserting data because you have to move all of the other data around to get the tree into the right shape to accommodate the new data. So it's not great for things like ingesting millions of traces per minute. ClickHouse has a solution to that in its merge tree engine and uses a thing called log structured merge trees. So basically what this is doing is it's taking all of that data that's coming in and storing it in memory and buffering it. And then as memory gets full, because memory is expensive, right, it's going to flush it to disk into these smaller sorted files that are organized efficiently for those reads, right, sorted by the indexes so that we can read them very efficiently. But these still aren't quite great for our really fast querying because it's a lot of really small files, and that is slow to read and index and analyze when you're running a query. So ClickHouse has a solution for this also. And what it does is in the background, it actually compacts those small files into larger and larger sorted files so that we end up with something, a format that is both very efficient for reads and very efficient for storage on the disk, while maintaining that ability for very rapid ingestion at the memory layer. So this is kind of the heart of what makes ClickHouse great for observability. And this storage mechanism also lends itself to observability in a few other ways. Besides the very fast writes, if we're partitioning our data based on time, which we typically are in observability, right? Because we're having data coming in and we just say, okay, this is my bucket, this is my bucket, this is my bucket. That lends itself naturally to the structured log tree mechanism. It also provides for easy cleanup because we can just say, oh, if we have a retention policy, we'll just throw away the buckets once they reach the end of the retention policy. So we have a very easy way to clean up our data, knowing that we're not throwing away anything recent and relevant. And all of that lends itself to it being a very cost-effective solution. For those reasons and for some of the other reasons that we'll talk about in terms of how you can actually store the data long-term. It also has a few other really, besides the storage engines, right? ClickHouse also has some other really cool features for observability. For managing the data inside the database and almost like building an application out of the data inside the database that presents itself almost like an API. One of those features is materialized views. So this lets you take data and basically project it into a different schema as it's inserted into the database, which is really useful if you want to, for example, take data in one format and present it in another format for another tool, which we'll look at querying later, which does that. We talked about how we can have really efficient retention policies using the built-in TTL of ClickHouse. And we also get tiered storage. We get the ability to say, this is my really important data. I want it on local disks accessible to each ClickHouse node. I want it replicated a certain amount. And then we can have long-term storage using formats like Parquet and on destinations like S3 that are much more cost-effective and scalable for if we have, for example, audits that we're subject to and we need to keep a certain number of years of data instead of the days or weeks that is typical with observability. So those are some of the features that make ClickHouse awesome for observability. And this has led to a number of integrations being built within the community that integrate ClickHouse with open source observability tools. So the Grafana data source plugin, there are actually two Grafana data source plugins, one maintained by Grafana and one maintained by us at Altinity. Both are great. Our plugin has some macros that make it easier to sort of manipulate ClickHouse data into the specific formats that some of the Grafana visualizations are expecting. Then there is Jaeger, which is a great open source tool for distributed tracing. And it has the option to use ClickHouse as its storage backend. You can just, give it a ClickHouse instance when you're configuring it and deploying it, and it will go ahead and use ClickHouse. There's CLoki, which, similar to the Jaeger backend, is a ClickHouse backend for Loki, for logging. And ClickHouse itself has a Kafka table engine built into it. So you can actually just point your Kafka stream at your ClickHouse instance and store everything, which if you're the type of organization that already has all of your observability data in Kafka, that's a pretty convenient option to take advantage of. And then we get even more integrations through the amazing ecosystem that is OpenTelemetry. There's an OpenTelemetry exporter for ClickHouse that can export metrics, traces, and logs to your ClickHouse database. And that opens up all of the potential receivers. There are more than 90 in the OpenTelemetry ecosystem. These are just some of my favorites right here, right? Prometheus, eBPF, in particular, we're going to look at with some of the tools later. And there are yet more benefits, right? We get excellent compression because of the way that data is stored using the log structured merge trees, and because of the way ClickHouse extracts data from columns and stores things columnary. So we can do things with compression, even if we have a variable schema, right? We have resource metadata. We don't necessarily need to know ahead of time what keys are going to be in that resource metadata or what those maps are going to look like, and we can still get really good columnar compression on that data. We can get practically unlimited cardinality. I say practically unlimited because it's really just orders of magnitude more. Cloudflare did a great presentation at Monodrama this summer where they talked about how, in Prometheus, low cardinality means dozens. In ClickHouse, low cardinality means, so when we're trying to deal with resource metadata, and we are still kind of figuring out and optimizing our system, and we haven't figured out exactly how we want to instrument everything and what data is valuable to keep, well, ClickHouse can accommodate us while we're on that journey, while we're working on optimizing things. And once we have got things optimized, as we grow, right, ClickHouse is very scalable, as we've discussed, for the reasons of the log structured merge tree and the other technology. But it's not perfect. If it were perfect, everybody would be using it. So the first challenge using ClickHouse for your observability is that SQL is not PromQL. And a lot of SREs and a lot of operators are already really familiar with PromQL. It's very deeply integrated with the ecosystem, with the tools, with Grafana, all of the off-the-shelf Grafana dashboards, right? PromQL is an extremely productive tool that many of us are familiar with. And when you try to recreate PromQL queries in SQL, dealing with time series data, it can get pretty gnarly pretty fast. Now, there's an asterisk there because both ClickHouse Incorporated and we at Altinity are working on this problem to make ClickHouse more and more compatible with Prometheus. So there is already the option to send Prometheus data to ClickHouse and use a time series storage engine for that data that's specifically optimized. And something that's probably coming in the future is the ability to actually use PromQL directly with that Prometheus data that was stored in ClickHouse. Another challenge using ClickHouse for observability is that it can be overly complex for small data volumes. Now, this bullet point comes pretty much from the ClickHouse Incorporated blog on ClickHouse for observability. I kind of disagree. Their definition in their blog post of small data volumes is 150 gigabytes. Whether or not that's small, I don't know. We have some customers who their entire data is less than 10 gigabytes, and they don't find ClickHouse to be overly cumbersome for that. They find it to be very efficient and productive tool. And I also would say that 150 gigabytes, I generate that much data, from some observability tests running for a week. That's not a lot of observability data. You could get to 150 gigabytes very quickly. And the last challenge is a big one, right? ClickHouse is just a database. As much as I love all of these other features, and I'm talking about how you can use them to kind of massage and manage your data while it's inside the database, it's not a turnkey observability solution by any means. It's just a storage engine. So that's something where some community tools and some products are coming to actually solve the next challenge in OpenTelemetry. Right? OpenTelemetry project does not include any kind of database or backend UI. So what we need is a complete solution that gives us the application SDKs. Thank you, OpenTelemetry. We've got that checked. Host and node agents. OpenTelemetry Collector is great here, and a lot of the tools that I'm going to be looking at later have their own distributions or configurations for the OpenTelemetry Collector. There are also eBPF node agents and other forms of node agents that are open source and really interesting and effective. For collection, sampling, and processing, Kafka and the OpenTelemetry Collector are the two obvious choices. We've talked about ClickHouse as your storage at length. You might use the OpenTelemetry Collector again as a storage gateway to sort of buffer some of the things coming into your ClickHouse instance. And then finally, right, we need to actually make use of all of this. We need to actually do something with this data because otherwise we're just paying a lot of money to store it on hard drives. We need an analysis UI that empowers our SREs to ask questions about the data, ask questions about the system that it represents. We need alerting mechanisms. And we need more than this too, right? This is simplified. I've given the hint of the idea of full circle observability, where we're looking at our analysis and feeding that back into how we're actually collecting and sampling the data so that we can make more effective decisions and use the data more efficiently and more moving forward. So we need something that empowers all of this, and ClickHouse alone can't do all of this. We need an ecosystem, and it's growing. So this is just a short list of observability tools that specifically use ClickHouse as a backend. And there are more observability tools out there that don't use ClickHouse as a backend. But for this talk, I'm going to focus on the ones that use ClickHouse. And specifically, I'm going to focus on Coroot and Querying because they're two that I hadn't heard of, and I think that maybe you haven't. And they're really cool, and they're fully open source. So I just want to talk about them a little bit. But Signos is also really cool. I'm sure you've heard from them today, some of the really awesome things that they're up to. Cognitive is kind of brand new, and I encourage you to check it out. And then all of this, of course, all of these tools can be used to build your own solution if that's something that your organization has the appetite for. So Coroot is the first tool that I want to look at. Coroot is really great because it's batteries included. You can just Helm install, and on a vanilla Kubernetes cluster, you're going to immediately start to get some observability of both the cluster and workloads running on the cluster. I say no code observability because you don't need to install an SDK or anything beyond the node agent in order to start getting value out of CodeRoot. So there's an example of that. Here is a screenshot of the CodeRoot service health dashboard. This is on a cluster where I have the OpenTelemetry demo project running, and I haven't done anything to integrate it with CodeRoot. I haven't pointed my OpenTelemetry collector at CodeRoot, which you can do. I just haven't done that yet, right? This is what you get out of the box. And so this is powered by eBPF, and that's built into the CodeRoot node agent. And this is really awesome for giving yourself this quick health check, right, of everything going on in your system. And you can see how this could really quickly give you a checklist for understanding the services where maybe you want to add more instrumentation or fix existing instrumentation. Using eBPF to trace the connections of OpenTelemetry collectors is really great when you're deploying observability solutions. So that's the starting point of CodeRoot. It's also doing eBPF tracing, so you get service graphs and topologies right out of the box. This is really cool. And then you can't quite see this because it's cut off, but there are logs at the bottom here. So this is kind of an example of the idea that I've been talking about of this context and correlation, this cross-signal correlation. Here we can see that we have the topology, which is derived from the eBPF traces. We're looking at the log screen, and we can see the little red circle there. That's based on health checks that are coming from a combination of metrics and logs. So we're using all three of those signals on the screen. And there's also that profiling tab that would have CPU profiles available, right? So we have all of the signals that are relevant to this specific instance of this specific service. And that is really the magic in this screen. It's not that I can pull all of the different signals, it's that they're already correlated for me around the same logical entity. And I don't have to do that hard work of making sure that I'm looking at the same thing during the same time window because I'm using 4 different tools. Okay, now CodeRoot is awesome because out of the box, it gives us all of this stuff. And that correlation part is really easy for CodeRoot because it's using its own node agent, so it knows the format that everything is coming in, and it's using the OpenTelemetry formats, which give us a starting point with the resource semantic conventions. What do we do if we don't have a vanilla starting point? We already have a bunch of tools that we're using for our observability. Well, querying, if I'm saying that right, and if the creators want to correct me, I welcome it, it's awesome, right? So it's basically acting as a compatibility layer where you can ingest all of your data using any of the formats supported by OpenTelemetry or any of these APIs, the LGTM APIs. And it stores it in ClickHouse, and then it also presents all of the data using all of those APIs. So say you have logs coming in from OpenTelemetry, logs coming in Loki format, logs coming in from FluentD. You can put all of those logs into the same ClickHouse table and then export all of them using OpenTelemetry, or provide a Loki API and integrate that directly into Grafana as if it were a Loki instance. Do the same thing with Tempo for traces, right? So this is a really cool tool if you already have these other tools and you want to make them talk to each other without necessarily duplicating the data. Right, we're getting all of that data down into the single pipeline that we want, and so we can kind of see some of the sources. Querying supports, there are a lot, and then it provides again those LGTM APIs and an OpenTelemetry API, Prometheus, of course. So a quick comparison of the two tools. CodeRoot has its eBPF node agent for automatic instrumentation. It does accept OpenTelemetry data via an OpenTelemetry collector gateway that it deploys as part of itself. And it uses the standard OpenTelemetry exporter schema, right? The schema that is created by the OpenTelemetry exporter for ClickHouse, that's part of the contrib collector. That's the same schema that CodeRoot uses. It just uses the contrib component. It does have its own schema for profiles since those are kind of new, but I expect that they'll standardize as the profiling spec gets integrated into the contrib collector exporter. Querying, since it has its own schema that it uses for the data that has some benefits that we'll talk about in a little bit, it does have its own exporter that you need to use in order to get the data into querying when you're talking about OpenTelemetry, right? It presents those APIs if you want to use those other APIs. And then it projects the data into compatible formats using ClickHouse materialized views. pretty powerful use of materialized views. So there are some things that all of these tools, and this actually includes Signos and some of the other tools that I've looked at that are using ClickHouse, there's some similarities in things that they're all doing with schema that just kind of makes sense when you're managing observability. We want to use pretty good compression, right? We want to trade off compression versus CPU, and that's a pretty good compression choice. We want to use delta encoding. It's just more efficient to store deltas than to store raw values. And we want to use Bloom filter indexes for maps. This includes our resource entities and metadata. And full text search of our logs, right? We want to use token Bloom filter indexes. And then we want to use merge tree engine for storing our data. That's the log structured merge tree that we looked at earlier. And we want to partition that data on time. It's the only way that really makes sense for observability. We also want to order it by time, of course. And most of these tools default to a 7-day TTL or retention policy. You can change that just by modifying the schema. I would say a 7 to 14-day retention policy is pretty common for real-time observability tools. The OpenTelemetry collector exporter for ClickHouse has some specific choices that it's making in the schema that are great for observability data, right? We're using maps for the resource metadata, JSON maps. We can actually make these more efficient than the ClickHouse exporter if we order them. There's a video on our YouTube with Justin Mason from MongoDB where he talks about how that can dramatically increase the compression ratios that you're able to get from unstructured maps. It's using the token Bloom filter indexes on the logs for really efficient full body text search. And it's using a materialized view to calculate span durations, another really cool and productive use of materialized views. Querying has some other cool tricks up its sleeve. So querying is really optimized around time series and time series labels, right? So they're using fingerprints and indexing based on those fingerprints that come from your labels in order to speed up time series queries even faster than what is possible with the already sub-second queries that you can get with ClickHouse without these tricks. They're using the replacing merge tree, which allows for efficient updates if you do need to update your data, which some of these APIs allow for. So it makes sense that querying would support it. And it's using the null table engine for raw ingest. So this is basically an in-memory engine that we can write data to very, very quickly and then use it as the source for materialized views to persist that data onto disk in the various formats that we need it as the processing space is available. So really quickly, let's talk about how we could scale something like this for production. When we're using the OpenTelemetry collector, it can get tricky because a lot of these tools that I'm showing and a lot of other tools want you to deploy an OpenTelemetry collector as part of it. And you could end up with a ton of daemon sets and deployments. So what you want to try and do is reduce that down to one daemon set and one deployment at most. The daemon set runs on every node. That's useful for gathering your node metrics, running any node agents, and collecting telemetry from any services running on those nodes. The deployment, that's useful at large scale because you need a gateway to sort of manage the data flowing into ClickHouse, and you also want a centralized place to apply all of your filtering and sampling rules that can be scaled independently of the daemon set. Then you want to deploy ClickHouse, also replicated, right? Because this is production. For replicated ClickHouse, we need Keeper or Zookeeper, again, replicated. And the Altinity operator is a really great tool for getting both of those things. Provides CRDs, so we can get a ClickHouse cluster with Keeper just by adding a CRD to our cluster as long as the operator is installed. In addition to those CRDs, it also helps with PVC management, right? Some of the things that are really challenging with running a database in Kubernetes, the Altinity operator can help with those. So rolling upgrades, it comes with some built-in monitoring via Prometheus and Grafana dashboards. It's got a bunch of other features, but those are just sort of the big ones, and I definitely recommend you check it out. Now, we've talked about a lot of things, and I kind of showed that incomplete observability solution graph. We didn't talk today about alerting and some of the other things that you need to deal with, like adaptive observability. That's the topic for another day. We're going to talk about that, right? And I hope you can see that how simplifying our tool chain can simplify how we build out these other pieces as well. So just to conclude, why unified observability storage, right? The first 3 bullet points, simplified management, simplified scaling, cost management, that really just comes from running one tool instead of 3. It kind of just makes sense that that is going to be easier. Having the standardization and normalization of metadata comes from having it all in one tool, but we still have to do a lot of work, right? It's going to be easier if we clean that data up before we store it. ClickHouse just gives us the opportunity to then also do more cleaning, more refinement, more things like post-hoc dependency mapping. And all of this powers the ability to do cross-signal correlation efficiently within a signal tool. Thank you very much. That's all I have, and now we'll have time for some questions.